This video is on the relationship between acidity and resonance. Resonance is the most important stabilizing factor in organic chemistry, and therefore if we're worried about the stability of conjugate bases, we need to look for resonance. Let's look at these two examples. Two organic molecules reacting with water to form the conjugate base and hydronium ions. In the first example, we have no resonance stabilization and we get a pKa of 13.5. Whilst in the second case, we get a pKa of 4.8 just because of resonance stabilization of the conjugate base. Remember that pKa is a logarithmic scale, so that is in fact practically 9 orders of magnitude difference. There's a huge difference in acidity. Time for a practice problem. Which one of these two is more acidic? You may pause now. And the answer is relatively clear if we look at the conjugate bases. The one on the left is clearly more stable and more acidic because of the resonance stabilization, whilst the one on the right does not have stabilization. This can be discerned if we look at the pKa's. You might be wondering though, as you reminisce that resonance going around the ring, and we know that that's going to have more than one resonance structure, how come the pKa is 10 whilst the one that we see up here is a pKa of 4.76? Yet that one only has one resonance structure. Well, turns out it's not just the number of structures, but it is also what atoms the resonance goes to. For example, if you are able to resonate to an atom that is more electronegative and likes to be negative, it is going to be much more stable. Hence, the one with the oxygen is more stable than the one with lots of resonance structures onto carbon, which doesn't really like to be negative. This can be further emphasized by looking at these three compounds. The first structure has no resonance and its pKa is 50. The second one can form a conjugate base with resonance, where the charge is always on carbon and its pKa is 44. In the final structure, we can have resonance where the negative charge ends up on oxygen, which of course likes to be negative, or at least is more stable as being negative, and we clearly see that in the pKa, which is 20. Now you don't need to remember the pKa's per se, but do remember the relationships between the pKa and the stability of the conjugate base. You should be able to look at two structures and judging by the resonance and what atoms are receiving that negative charge, you should be able to say which one is more acidic or less acidic, or has a higher pKa or a lower pKa.